Yes, class. Am I audible to all of you?
Yes, ma'am.
So who all have joined? Astha, Abdullah, Sahib. Abdullah, you have joined a lot of time back. You were not attending classes, Abdullah. I think this is your third or fourth class only. Ahmed, Usman, Anushka, Emma, Jiva, Razan, and Zaid. So Zaid, you already had a class in this batch? Zaid?
No, I didn't.
So this is your first class?
Yes.
Okay. And what about you, Abdullah? You already had a class, no, I think? 1 or 2 classes you had? Or is this also your first class? Abdullah Sahib.
Yes, miss.
Okay. So yes, class, in the last class, we had started with instantaneous power. Basically, power and energy we were completing. So power and energy are there. We had seen the formula as well, formula for power. Now, formula for power basically involves what? Your ERMS, IRMS, and cos phi. What was the term that was assigned to cos phi? There was a certain term, no? We said that cos phi is also known as
Power factor.
power factor. Good. This is also known as power factor. So basically your power that you refer for an AC circuit, it is ERMS, IRMS into cos phi. Fine. And cos phi, phi is the phase difference between the voltage and current. Voltage can also lead current by any angle. Usually it is 90° for the circuits we have studied. And current could also lead the voltage, or both can be in the same phase. But both can be in the same phase for only one type of circuit. What was that type of circuit? One type of circuit was there for which power factor was unity. One circuit where voltage and current do not have any phase difference, or both are in the same phase. Yes, among all the circuits, which circuit is that? Capacitive circuit, inductive circuit, resistive circuit. Voltage and current have no phase difference, or you can say voltage and current are in the same phase. Yes, good. Ahmed, Rizan, only resistive circuit, purely resistive circuit. There only we had seen no current and voltage both were in the same phase. In rest of the circuits, someone was leading other. Either it was voltage leading current or current leading voltage. All right. We didn't do any numerical on this. Let's just complete a numerical. I think a numerical was left. Rest of the things we had completed. This derivation we did. This was the formula, ERMS into IRMS into cos phi. Now, ERMS can be written as E naught by root 2 also if you want to write the peak value. IRMS can be written as I naught by root 2 if you want to write the in terms of peak value. And cos phi is the power factor. Power factor basically means cos phi's value. And phi here is the phase angle. Whatever be the phase angle between current and voltage. Let's do one question on this. This proof we did it. Okay, a light. Let's do this question. A light bulb is rated. A light bulb is rated at 100 watt for a 220 volt supply. Okay, so power is how much? Power is 100 watt and ERMS is given to you as 220. Yes, this is alternating current going on. So we are almost towards the end of alternating current. Like power is one question we have to do. And after this question, we'll complete transformers. So transformers will be completed in today's class only. And then we'll start with EM waves. All right, Zed, this is what we are currently doing. And what about your school syllabus, Zed? Which lesson is currently going on there? And others, did you all have your half yearly results now, by now? All those who received their answer sheets, let me know whatever you are scoring. Accordingly, we'll plan out the revision and how much progress a student needs to have. Let me know whatever scores you are receiving. If you are not comfortable in sharing in the class, then at least answer in the chat box. Yes, Anushka, you were saying something.
No, ma'am, I was saying that in our school we have not done the half yearly yet. We have in 7th November.
Okay. Yes, Anushka, I remember. In some schools, they are going in the month of November. Okay, they have finished EM waves and they must be on ray optics now, sir. All right. So we are going to start with ray optics. And all those who have had their exams, midterms, UTs, let me know whatever scores you are getting in school. And also, if it's possible, do share your question papers on WhatsApp so that at least you will be prepared. All right, so power is given as 100 watt, 220 volt is the supply, that is ERMS value. Calculate peak voltage, that is E naught, resistance of the bulb, RMS current through the circuit. Quickly note this question. It's a very direct question. ERMS is there. Okay, ray optics, they'll start tomorrow. All right. See, power is there. ERMS is there. Using ERMS, first let me know what is the peak value of the voltage source. Once you have the peak value of voltage, what is the resistance of the bulb? Resistance you will be calculating using power, voltage and resistance formula. And IRMS you have to calculate. Quickly, at least second part you people can do. Quickly note down the question. This is 100 watt for 220 volt. Take 2 minutes, then I'll discuss with you. All right, let's discuss it. I think this was sufficient time. It was a formula-based question only. See, ERMS is given and we have to find out the peak value. So there's a relation between the peak value and the RMS value. Difference is just of √2. So here, for the first part, peak value of voltage, that is E naught. E naught by √2 is equal to ERMS. So here ERMS is 220 volts. ERMS is given as 220 volts. And E naught is asked. So E naught will be what? E naught will simply be 220 multiplied by √2, this much volts. Second part says resistance. Resistance of the bulb is to be calculated. See, resistance will be what? Power was given how much? 100, no? 100 watt. So if power is given as 100 watt and voltage, that is ERMS, you have it as how much? 220. And resistance is not given. See, there's a relation between power, voltage and resistance. P is equal to V square by R. In general, using current electricity, you must have studied this also. So P is equal to V square by R. From here, R will be equal to what? V square by P. And now if you write this formula in terms of ERMS, so resistance will be what? Resistance will be ERMS square by power. So that makes it 220 whole square divided by 100. So here this will be your answer. Screen is sharing with you guys, no? Are you able to see the screen?
Yes, ma'am.
Okay. Okay. Okay, so we were discussing. So resistance will be 220 whole square divided by 100. Now what will happen? See class here. You get the value of resistance. Once you have the value of resistance, what will happen? Current, voltage and resistance, they have a relation. This will be 484 because zeros will get cancelled. So this will be 484 ohms. Now for the third part also, if you look here, for the third part as well, current is unknown, IRMS is unknown, so this will be ERMS divided by resistance. ERMS is 220, resistance is 484. This much of ampere is the I think by now all of you have written it. Let's now complete with transformers. Okay. Now see, just understand what is meant by transform. Transformer is a very easy topic. Actually, it's the easiest topic of alternating current. The topics before what we have covered till power, some of the topics are tricky and it takes time to understand. But transformer is the easiest part of alternating current. So just understand this topic, and if a question comes from this part, your transformer, you should be able to answer it, because the formula also is not difficult. The lengthy formulas are not involved here. Transformer is basically a device that converts alternating current which is at low voltage to alternating current which is at high voltage. This is one possibility. The other possibility is that my voice is not coming.
It's lagging.
My voice is lagging. Internet issues. Is it better now, class?
Yes, ma'am.
Okay. Please let me know whenever voice is lagging, because it must be because of internet issue. See, I was saying transformer. Firstly, I have said that when we had started just this, that transformer is a very easy topic from your alternating current. So very easy formulas are there. Direct formula based questions are asked from this. So just focus on transformer and you'll be able to score in this if a question comes from transformer. Theory part is easy, working is easy, construction is easy, not difficult as the magnetics constructions and the moving coil galvanometer, all these involved. This is simpler. Principle also, you already know the principle of it. This principle of transformers you have already covered in electromagnetic induction. So most of the things you are aware of, just a slight help in transformer will help you do it. Now transformers are what? Transformers are basically electrical devices. Now they do what? Either, first point, they convert alternating current which is at low voltage to an alternating current which is at high voltage. Or it can perform the work of converting alternating current at high voltage to alternating current at low voltage. It does this work only, converts electrical device which converts an alternating current at high voltage to low voltage or low voltage to high voltage. This is what is the work of a transformer. Now, depending upon this, transformers are of two types. If you have the voltages which are converted from low voltage to high, alternating currents are changed from low voltage to high. It's like from something low, you are stepping it up. From a low portion of voltage, you are raising the voltage. Something that is getting up, rising up. So you say these types of transformers are known as step-up transformers. So step-up transformers will be what? Step-up transformers will be simply transformers which convert alternating current at low voltage to alternating current at high voltage. Step-up transformers. Clear? Now, opposite to this, if you have the transformers that convert alternating current at high voltage to alternating current at low voltage. From high to low, you are pushing something down. Something is getting down. So this is step down transformer. Clear? Step up transformer was what? Step up transformer is simply a transformer that converts low voltage to high voltage. Step up transformer, something that is rising from low voltage to high voltage. Then you have step down transformer, voltage that is high to the voltage that is low. Step down transformer, step down transformer. These are the two types of transformers that we classify depending upon the type of voltages they convert. Now you have types of transformers depending upon depending upon their construction also, but before the construction, no, just have a look at the definition. So yes, it is an electrical device for converting and alternating current at low voltage to high voltage or vice versa. Means high to low as well. Low to high, yeah, high to low. In दोनों में से कोई भी. Either it can be low to high, high to low. Now, if it is from low to high, if it is from low to high, let's see, low to high, it means it increases the input voltage. Input voltage is being increased up. This is known as step up transformer. This part, these type of transformers, these are known as step up transformers. Step up transformers, you are pushing something higher back. Fine, step up transformers. Then you have, again, opposite to this, you have transformers which decrease the input voltage. Higher voltage is there, they are decreasing the higher voltage. So these types of transformers are known as step down transformers. Very easy to remember, nothing is difficult here. These are step down transformers. Fine, step up transformers, step down transformers. Now coming to the construction of it. Yes, principle you already know, mutual induction. So why mutual induction? We'll see here only. So mutual induction's application is your transformers. Now have a look at this. This first one that you are able to see here, this is known as core type transformer. This is known as core type. Now what is meant by core type transformer? So see, core type transformer simply means there are two types, shell type and core type. Now how do we classify these? These are classified on the basis of their construction, right? Depending upon their work, the work they perform, we classified it as either step up or step down. Depending upon their construction, the transformers are classified as core type or shell type. Okay? Core type or shell type we have. Now, core type and shell type have a very slight difference. There are two wires present. Two wires, you can say two coils are present. Anushka, you are asking something? I'm not audible.
No, ma'am, I was not asking.
Okay. Just let me know, my voice is audible to you now, all of you?
Yes, ma'am.
Okay. If it goes in between, let me know. Zed, are you able to hear now? Okay. I think my internet is right now, it's fine. All right. So yes, I was saying, yeah, two types of coils will be there. Fine. Two types of coils. Coils are basically what? You just wrap up the wire. Wire is present. You start wrapping it up. This is known as a coil. That is what we had understood and learned for solenoid as well. This was only for solenoid. No, wounds of wires, turnings of wire. So same thing is here as well. So in core type of transformers, what happened? There is a soft iron piece in a rectangular form, concentric rectangular form. You have a rectangular piece which is soft iron. If the primary and the secondary coil. Both are separated from each other. That construction is known as core type. Now, what are primary and secondary wires? So, coils you have understood, basically just copper turnings, copper, aluminium, any conducting turnings. Now, what happened? We have already studied mutual induction. So, in mutual induction, what did we study? What was mutual induction? Can anybody remind me? All those who were present. Mutual induction we did study. Yes, Anushka, can you try once?
Ma'am, induction with self in the same.
That is, that is self-induction. Induction
Ma'am,
means,
can I try?
yes, Zed, please. Yes.
Mutual induction means like there are two coils. There are two coils. Due to the induction of first coil, second coil gets induced.
Yes, that is mutual induction. Good. Now, basically, the what did Zed say? In his answer, this fact was written that what actually is induction. In induction, you have magnetic field lines changing. This we had studied, if you all can recall. When magnetic field lines change, you have magnetic flux changing. And as the magnetic flux increases or decreases, you have induced EMF. That's why we have induced EMF is directly proportional to rate of change of flux. From here only, we get it. And if this flux is changed in one coil, and the induced EMF is also induced in the same coil, we call it as self-induction. If the flux is changed in one coil and you see the induced EMF or induced current in the other coil, that is mutual induction. Same thing will occur here. In primary coil, there will be change of flux, there will be change of the magnetic field, and because of which in the secondary coil, you will see IRMS or ERMS induced getting changed. So difference lies just in the construction. Rest for core and shell, everything remains. In core type, primary and secondary wires are held in the, you can say, ends of the rectangular slab that you have, soft iron core slab, and both are separated from each other. They are kept at a certain distance from each other. But if you see this case, here if you see it, see, this is known as a shell type. In shell type, what happens? Primary and secondary. This is the primary coil, this is the secondary coil. Coils have their turnings. They are kept in proximity to each other. In the first one, they were separated. In the second shell type, they are kept in closer contact. Same thing will occur. It's just the difference of the construction. And because of the construction, you have various changes and uses, and industrial uses just get changed. The rest of the thing remains the same. So primary and secondary's construction makes it different. All right. Now, yes, see, class. Rest of the things, for mutual induction, this is the same. Working is what? Working is the mutual induction only. Working of a transformer will be what? Definitely, it will be the working of alternating currents, mutual induction. So, working means as the alternating current, flows through the primary. Alternating current is flowing through the primary. It generates alternating magnetic flux which passes through the secondary. Did you get it? That's why two coils are involved over here. So due to change in the magnetic flux, induced EMF will occur in the secondary coil, you can say, secondary when you can do. And self-induced EMF will be there in the primary coil. This means primary coil is there, secondary coil is there. Both the coils are there. Primary gets the flux changed and effect you see in the secondary. But this is known as mutual induction. But if within the primary coil, some amount of self-induction also occurs within the primary coil. That is what is written in the working. Now coming to the formula part of it. But before the formula, I think you all should note it till here. Working, construction, and it. Note it till here, then I'll tell you the formula and we'll complete with one numerical. That will complete off with this lesson so that we can start with EM waves. And EM waves is a very short lesson. You have your test of AC tomorrow, no? I think I didn't announce it for today. The complete test of alternating current. It's tomorrow, no, Anushka?
Yes, ma'am. Yes, ma'am.
One more thing. Astha, you send your question paper to me as well. Score you have sent, no, send me the question paper as well so that I can get an idea.
Ma'am, I'll send in WhatsApp.
Ma'am,
Yes, yes, Anushka.
ma'am, the last test that we had conducted, you're not announced
Yes.
the mark.
I have not announced the marks. I'll today only. I'll today share it with you. I'll share it on the group only. By tonight, I'll share it.
Yes, ma'am.
EMI's test, no, you had Lenz law, that those questions you had 4 questions.
Yes,
no?
ma'am.
Okay.
Ma'am, can you scroll up once again? Yes, ma'am, done.
Done.
Yes.
Yes, ma'am.
Okay, see class. EMF's magnitude, we had already studied that EMF's magnitude was what? If you see your Faraday's laws of EMI, what we had seen, EMF's magnitude was simply rate of change of magnetic flux, d phi over dt. And we used to put a negative sign. This negative sign was because of Lenz's law. Lenz's law was what? That it opposed the cause that it produced it. So this was what we had studied. So E is equal to minus d phi over dt for a single turn of the coil. In case of transformers, what did we study? Number of turns can be variable. There was no any constriction regarding the number of turns that were present. So number of turns, if this is for a single turn, then if you have to multiply this whole term with the number of turns present. So EP is equal to minus NP d phi over dt. This is what? EP is voltage of primary coil, NP is number of turns in the primary, and d phi over dt becomes the rate of change of flux. So voltage in primary is equal to number of turns in primary d phi over dt. Similarly, voltage in secondary will be minus ns d phi over dt. Now see class, if this is the case, minus over d phi over dt, then see, if I take the ratio of EP and ES, I'll get EP by ES is equal to NP by NS. Now, how to remember this formula? Just remember one thing over here. EP, here you had P, right? Here is also P present. Here you have S, here you have S present. So whatever you have in the numerator, have the same thing in the denominator. It means if I say voltage in the secondary divided by voltage in the primary. So this means a number of turns in secondary by number of turns in primary only I will write. If secondary is there here, secondary will be here. If primary is written here, then primary will be written here. This is what I'm saying. So the best way to remember the formula is by this only. Voltage and number of turns will have the same coefficients. Now power is equal to voltage into current. This we have studied. P is equal to VI. Now, if you see here using this, can you notice, and you already know even without noticing this, that voltage is inversely proportional to the current. Voltage is inversely proportional to current. It means in this final formula that you will get, here you will be having what? See, EMF in primary divided by EMF in secondary is equal to number of turns in primary by number of turns in secondary. This we have studied till now. Voltage is inversely proportional to current. So here, if this is P here, this is P here, it means IS will be here divided by IP. This is the formula for it. EP by ES is equal to NP by NS is equal to IS by IP. If you write IP here, IS below, so mention and ensure that you write S over here. Interchange it. Voltage and current will have the different values for the different coils. Just this is the formula, nothing else, just the ratios will be involved. One thing here we can involve more is the power. So this is just the last part of this. Power is what? VI right now. So power for primary will be voltage of primary into current of primary. Power of secondary will be voltage of secondary into current of the secondary. This is just it is. And efficiency, I don't know if you all had done this last year in your thermal physics. You must have heard of coefficient of performance, performance for refrigerator and Carnot's engine, efficiency of a Carnot engine. In thermal physics, you had this included. I don't know whether it was done last year in your school or not. Yes or no? Ever heard of this?
Ma'am, I guess last year Carnot's engine that was deleted.
Deleted. It was deleted. Yes, Carnot's was deleted. All right. So yes, I think in your batch, last year this was not included. But earlier there was a part of these Carnot engine and refrigerator. So students were aware of this. That gives you efficiency of any machine. Efficiency and the symbol eta is represented for any machine. In the sense, how much efficient a machine is, how much heat loss is prevented by the machine. If heat loss is more power consumption, less power output, and more of heat, it means it is not good efficient. It has not good efficiency. So efficiency of a transformer is also important. Power output by power input into 100. This is the formula for efficiency. This can be asked to you in the maximum case. Usually you have that formula just now that I have written. That will be sufficient to solve it. All right, let's do a question. But before the question, I think note down these 2 to 3 points. Then you can copy them. And I'll give you a break of 5 minutes also before starting with EM waves. And please, class, be prepared with AC tomorrow. Okay, let's complete one numerical based on this. See, this says that primary coil of an ideal step-up transformer has 100 turns and transformation ratio is also 100. Number of turns in primary coil, that is, the coil often has 100 turns. So NP is given to you as 100. Number of turns in primary coil, 100. Transformation ratio means number of turns in secondary divided by number of turns in primary. So this is what is meant by transformation ratio. NS, if you divide this NS by NP, this is known as transformation ratio, which is given as 100. Input voltage is 220 volt. It means the primary power, primary voltage. All right, that is 220. And 1100 watt is the input power. So power input is given as 1100 watt. Input voltage is 220. 100 is NS by NP. NP is 100. All the things are mentioned. One formula we'll use and we'll find rest of the things. Number of turns in the secondary. See, number of turns in primary is given as 100 and NS by NP is given as 100. So number of turns in secondary will be what? Number of turns in secondary will be number of turns in primary into 100. That gives 100 into 100, which is equal to 10 to the power 4 turns. Fine. Which these parts are easy. The numericals also and transformers are easy only. Wherever you're not able to understand whichever part, just stop me then and there. Let me know whichever part is not understood. Voltage across secondary. So voltage across primary is given in the question as 220 volt. If you look at the question, it is given to you as voltage. Primary voltage is given as 220. So if you look for the second part, voltage in the primary is given as 220 volt. Secondary VS is asked. See, NS by NP we have, VP also we have. If we use the relation VP by VS is equal to, let's just take the reverse. And let's use a symbol EMF only, because otherwise it will become confusing. ES by EP is equal to NS by NP. So ES we have to find out. ES will be what? ES will be NS by NP into EP. So NS by NP is the transformation ratio. And if this is the transformation ratio, you can write it as directly as 100. So this is 100 into EP is 220 volt. If this is 220 volt, then directly you can write the value as 22,000 volt, voltage in the primary. Again, using this relation only, we calculated this. Next part was what? Current in the secondary coil. Okay. Power input is given as 1100 watt. See, power input means voltage in primary. Let me write here. Into current in the primary. Power input is given to you as 1100. Current in primary is given to you as 100 into IP. So current in the primary is 11 ampere. And current in secondary it is asking. Now current in primary is your calculation of current in secondary is not difficult. See, if we use the relation NS by NP, what did I tell you? Here you have to write IP. If you have, here you have S, then here you have to write P. So if this is IP, this will become IP by IS. So IS is only missing. IS will be equal to NS by NP into IP. So IS will be equal to 100 into, this is IP is 11. You will get here the powers value exactly. That is 1100 ampere. So IS is also here. So IP, IS, any of these are ours. You can calculate. Last part is saying power in the secondary. So voltage in the secondary you have. So power output is currents in the secondary multiplied by EMF in the secondary. So current in the secondary is 1100 amperes and voltage in the secondary was what? 22,000. So a big number we have here, 22,000. This was how much? Volts. So this is 10 to the power 5 will be there. Just a second. So yes, 10 to the power 5 we have, and this will become 242 into 10 to the power 5, this much of watt. So based on this only direct data, you have these kind of question. Now this line that has been written for ideal transformer or any machine that is ideal, any machine, if you say it is an ideal machine, ideal machines mean you do not have any heat loss or any wastage of heat does not happen. Those types of machines are known as efficient, highly efficient machine. Now see, in reality, any machine cannot be ideal. How can you have any machine where frictional force is not there, heat is not there? Every machine will somehow have at least some of the heat energy, right? All these phenomena will be there. So in idealistic situation, if you talk about, so ideal transformer efficiency is 100%. It means whatever power is you are putting into the machine, exact amount of power the machine is providing. The output power is exactly equal to the input power. This is just the difference. So this line has to be written after the fourth part, since no left space was left for the fourth part. That's why I've written it separately. So do write this line for ideal transformer after fourth part. So at least this completes your questions. All right, class. So note it down. Any part you have any issues, any topic you have issues. See, LC oscillation I did with you all because it is not included in your syllabus. So don't go into the details of LC oscillation. When we'll be doing revision, that time I'll tell you in brief. But no need to go into the details because LC oscillations will require one more class and it is not included now. So I'll tell you in brief if required. Otherwise, it is deleted in your syllabus. Maximum parts have been deleted. Some more things in your now second term have also been deleted. Only reflection is added in your ray optics, which was not there last year. And in EM waves, you have displacement current that has been added, that I'll tell you here when we'll complete with it. Otherwise, in your semiconductors, I think some more topics have been deleted. PN junction and rectifiers are only there. Any doubts you have, any queries you have, let me know.
Oh, ma'am.
Yes, who was asking? Asa?
Asta.
Yes,
Yes,
Asa.
ma'am. Ma'am, for the third part, isn't the EP 220 volts? You have substituted 100 instead of EP.
Just a second. In which part?
The third part.
This part only.
Yes, ma'am.
EP is how much? EP is, yes. I have substituted 100. 100 was the transformation ratio. Yes. Correct. Please make this correction. This is 220 volts. No, this one. Yes, this will be 220 volts. So I think this will come 5 amperes, no? This one,
Yes, ma'am.
current in primary. So then the upcoming answers will also be same. This was transformation. This will be 5.
Oh, ma'am.
Yes, Asta, say.
Ma'am, one more doubt.
Mhm.
It's NS by NP is equal to IP by IS. So when you want to find IS, it will be IP by.
It will be NP by NS. So that will become 1 by 100. Yes, right.
Yes, ma'am.
So this was, here we were finding IS.
Yes, ma'am. So it will be like 5 by 100, not like in.
Yes. This is 100. So here we'll have 100. Right. Correct. Here we'll have 100. And here this will be 1 by 100. So 5 by 100 you can write it. NS by NP will not be here. And we are having transformation ratio as NS by NP, no? Transformation ratio is given as 100. Yes, right, correct. All have completed or only Astha has written? Just text me done in the chat column, all those who have written. Okay, I think most of you have completed. So let's just have an introduction of EM waves. Rest of the parts of EM waves, I'll discuss it with you tomorrow. EM waves is a very, very short lesson that we have. It's a very short lesson. See, there are 3 parts of this lesson. Let me brief you with what is this lesson. So there are 3 parts of this lesson. First part involves what we'll do is about the electric field, magnetic field, and direction of propagation, and how all these 3 are related. So the first part basically involves 2 equations. One equation is there which is related to your waves equation, which you have already done in your class 11. That similar equation is there. So that is one part which involves this. It basically connects frequency with wavelength, wavelength with wave number, angular wave number, and 2 equations of peak value along with the peak value, that is amplitude, and the values of electric field and magnetic field. So basically the first part deals with magnetic field and electric field and their equation and their relations. Second part comprises of the electromagnetic spectrum. Now, electromagnetic spectrum completely you have to learn by yourself. I'll share the table. I'll share the table on the WhatsApp group as well. I'll discuss it once, but see, certain things are there. For example, one electromagnetic wave, let's take the example like gamma rays. So gamma rays have the highest frequency. They have the lowest value of wavelength. What is the exact value of frequency? What is the exact value of wavelength? Where gamma rays are used, like gamma rays are mostly used for the treatment of cancers. All these parts are, yes, I'll get you. Azad, what's your full name? Please just tell me what's your full name. Just write your full name. I'll get you. So I'll share the content there only. Yes, because Muhammad Zaiduddin. All right, sir. I'll get you. So this part involves like uses of gamma rays, production of gamma rays. So all these things are mentioned in NCERT also. Though I'll be sharing the material with you, but I'll suggest you all to go through the NCERT ones, because from this lesson, no, it has the minimum weightage. Minimum weightage is there, and you will be able to answer all the questions of it if you learn that table. From electromagnetic spectrum, questions will come definitely. And that spectrum, it's just rote learning part. The way we had in chapter number 5th, we had that table for diamagnetic, paramagnetic, and ferromagnetic substances. Everything was there to rote learn all these things. Similarly, you have it for electromagnetic spectrum. So I'll discuss it once in the class, definitely, but you all have to remember it. Do the learnings, but I'll take a test also. In the next week, most probably we'll have a test of electromagnetic waves also. Because it's a short lesson, it will take you less time also to revise it. That is a later thing, we'll discuss it. Last part of electromagnetic waves, which was not included last year, is recently been added. That is displacement current. Ampere's law is there, Maxwell Ampere's correction is there, Maxwell modified Ampere circuit law. Ampere circuit law, same Ampere circuit law which we have studied in magnetics. That was modified by Maxwell. So this part now about displacement current briefly is there in your syllabus for now, but it is recently added. So thing that, and topic that was not present last year, which was deleted last year and which has not been coming for the past 2 years, it has the maximum chance of coming this year. So displacement current and electromagnetic spectrum are very important, especially electromagnetic spectrum, especially for the students also who have to appear for their NEET or JEE or any kind of entrances after their class 12. For the admission in colleges, those who have to appear for the college entrances, For them also, from EM waves, a question that comes is usually from the electromagnetic spectrum. Even from the previous years, you will find questions from electromagnetic spectrum. You have to learn that order. Now, electromagnetic waves are what basically? What do the electromagnetic waves this lesson deal with? So this lesson basically, from the term only you can say, and this is the last lesson of your first book. So it means your first book totally comprises of electromagnetism part. The second book is entirely different. Next Saturday, we'll be starting with ray optics, reflection of lights we'll start with, and you will see nothing is connected over here. Till now, did you notice? We were using all the terms that we had studied. Magnetic flux will also be involved over here. Magnetic flux will be involved over here. Ampere circuital law will come over here. Gauss theorem will come, whatever you have studied. So all these things. So first book is totally about magnetism. Similarly, in electromagnetic waves also, electromagnetic waves means what? This lesson, that is your chapter 8. This is chapter 8 of NCERT. So electromagnetic waves. This means simply, this is the electric field part, and this is the magnetic field part. Now see, this basically says, no, 2 points are there which have to be learned. 2 points are there. 1 point says the fact that if electric field is time varying electric field means an electric field which is changing as the value of time is changing. For example, at t is equal to 0 seconds, some value of electric field exists. At t is equal to 5 seconds, some other value of electric field exists. At t is equal to 10 seconds, value of electric field has changed. If we talk about a normal circuit that we have where electric field is present, electric field's value is constant. Let's say 5 volt per meter. So it will remain 5 volt per meter. Or let's take some, like, even if it is negative, minus 3 Newton per coulomb, whatever it is, the value of electric field, that will remain fixed for it. So time varying electric field is there. It means electric field is depending upon time. As the time is changing, your electric field is also changing, right? So time varying electric field. Time varying electric field this was observed that this produced magnetic field. An electric field which was variable, this produced magnetic field, and contrary to this, it was observed, one more fact was observed in this only, that if you have time varying magnetic field, then it will produce electric field. These two conclusions were drawn by scientists. That's due to their experiments, due to their certain observations, and they could see that magnetic field also was depending upon time. That magnetic field could produce electric field, and if electric field is variable, it is depending upon time, that can also produce your magnetic field. So this relation was there. So some things were established between magnetic field, electric field, and it was concluded that a ray or wave that travels within this time varying electric field and this time varying magnetic field, it was termed as electromagnetic wave. And as soon as discoveries were made, then it was realized that there are certain waves in this that can form a spectrum, and a spectrum was formed where different rays were present. Different rays were present, as in you have certain rays. See, I'll name it the way you have the complete Vibgyor. You have it for the rainbow color. Similarly, here you have gamma rays are there, X rays are there, ultraviolet you have, visible you have, infrared radiations you have, microwave you have, and radio waves you have. This is the order of it. Fine. Now from here, no, that I'll discuss when we'll do. Gamma rays have the highest frequency while the radio waves have the highest wavelength. It means this has the least wavelength and this has the least frequency. So certain observations were there, and all these things you have to remember on. But it was finally concluded that yes, electromagnetic field could be established. Now, what is electromagnetic wave? This you can understand from this figure. Look at this carefully. See here. What is meant by this graph is particles are there. And if you combine all these particles together, there are different particles in a wave. If you combine all these particles together, you get a complete smooth wave. So basically, electromagnetic wave is what? In the introductory part only, this has a wave where electric field, magnetic field, and the direction in which the wave is propagating, all these are directly perpendicular to each other. It means this ray diagram shows what? This, not this ray diagram, this graph shows what? This graph basically shows, look here carefully. This graph shows that electric field is lying along the y-axis. Can you notice? See, this is lying along the y-axis. This red one, this is the electric field. Then you have the magnetic field, which is along the z-axis. Notice the points of this is lying along the z-axis. This is not along the x-axis or y-axis. It is along the z-axis. So electric field was where? Electric field was along the x-axis, magnetic field was along the z-axis. And the wave itself is moving towards the x-axis. This was y. And the direction of propagation was towards the x-axis. And what do we know about all these three axes? That all these are perpendicular to each other. This was what was meant by electromagnetic wave. So even the definition of electromagnetic waves that we have. So electromagnetic wave. An electromagnetic wave is a wave radiated by accelerated charge and propagated through a space as coupled electric and magnetic fields oscillating perpendicular to each other and perpendicular to the direction of propagation as well. It is not only perpendicular to each other, it is perpendicular to the direction of propagation as well. This is what is meant by electromagnetic waves, and we will be learning more about electric field and magnetic field. All right, class. Copy this part quickly. I think time is also not left. You don't even copy it right now. In the next class, tomorrow you can copy it. Your time is already up. So otherwise, your class will get exceeded. So you can copy it later, or you can take the screenshot of this page. Take the screenshot, note it down in your notebook. Tomorrow I'll give you time, 5 minutes before. No, other students keep on joining. Students keep on joining. I'll give you time. Write it down. So electromagnetic waves we'll do. I think displacement current portion will be left tomorrow. Rest of the part will be completed tomorrow itself. I think a very small portion will be left tomorrow. So that we'll do on next Saturday, and we'll start with ray optics also on next Saturday. For tomorrow, we have electromagnetic waves to complete, and you have your test of alternating current. All right. For Z, then someone who has not attended the classes of AC, if you are comfortable in giving the test, you can appear the test. Your marks will not be submitted, or if you wish, I can submit your marks as per your choice. Or you can even take the screenshot of the paper and can send me as an assignment. That is totally up to you. But rest of the students who have attended the class please attempt the test of AC, because alternating current becomes very confusing once you start revising it. All right, all the things get mixed up and the answers are not get coming. All right, so tomorrow let's meet. I'll share your scores today. Okay, thank you.